Okay, welcome to JC Connect. Um, and, we are discussing about the different types of cements and how exactly uh, the different types of cements are going to affect the, uh, the strength of the quantity. So normally it depends on the chemical composition also. See, the chemical composition that I already explained, how exactly the chemical composition has to be calculated using advanced equipments. Um, One thing we have to always remember that whichever the cement you select it, uh, these two contents are very important. That is, C3A, C3S. So it is tricalcium silicate and tricalcium aluminate. So I already said that um, the manufacture of cement that has used CaO, that is lime, and SiO2, then so calcium it will come from this, and silicate it will come from this, and Al2O3. Okay, always you have to remember some traces will be there, that you have to keep it in mind. Always the Portland cement hardening we have discussed previously, and strength it depends on the composition of the processed clinker. Okay, the strength properties are much depends on this tricalcium silicate content. So in general terms, this means that higher the CaO, very important, higher the CaO, the better the hardening conditions. That you have to remember. Better the hardening conditions. So similar to your, it will be similar to your body bones conditions. If any problem are going to happen in your bones or muscles, okay, always the doctors will provide the calcium tablet first. Okay, the calcium is main component in your the, the bones. Okay, um, so this content has to be increased. So automatically the hardening conditions are to be better. Okay, so then SiO2 it is also an very important, as well as the alumina. Okay, so whichever the things or whichever the type of cement you study, the variation of proportions in this is going to affect the different types of cements. Okay, as well as the different types of properties also. Okay, so then quick settling of the cement is also very important, and the low heat cement, so the formation of cracks in large body of concrete due to the heat of hydration has focused the attention of the concrete, which produces less heat at low rate during the hydration process. A low heat evaluation is achieved by reducing the contents of the these two, which are the compounds evolving the maximum heat of hydration, increasing the C2S. So either it is dicalcium silicate, tricalcium silicate, or dicalcium aluminate or tricalcium aluminate. Of course, these are um, more predominantly we'll use it, and the composition is also very much important. Of course, we'll not go in detail about this chemical composition, but if varying the proportion of the C2S or the C3S or C4S is definitely going to affect the property of the cement. Then Portland pozzolana cement. So for this, um, you refer this how exactly the properties are going to affect the types of cement. Of course, we'll not spend more time in this. Okay, um, but still, the second module we have to cover um, the some of the estimation part and the tests on bricks, tests on concrete, and the tests on steel also we have to cover. Just go through it. Have any difficulty, we'll have a discussion at the end. And just refer all these things. Portland pozzolana cement. So this you already know how exactly uh, the mixing has to be done. Okay, you want to cement mortar, cement mortar. Of course, leave this. As you already the proper mixing, how we are going to, if you are preparing the cube, how you have to mix, how you have to um, um, maintain the time, what will the mixing time, how much quantity of water you have to add, and all those things, how much temperature you have to maintain. Normally this you have to keep it in mind. Okay? And what will the motor size and all those things. So then we'll move on to the tests on concrete, which are the tests we are going to conduct on the concrete. You already know that which are the components of concrete. So um, air, cement, coarse aggregate, fine aggregate, and water. So these are all uh, things are required to make it concrete. Okay. Previously, whatever we have discussed, that is related to completely cement. Okay, so which are the tests we are going to conduct on the cement. So normally it is for 10 marks. Whatever we discussed now, discuss the which are the tests we are going to conduct on the cement. So then see the marks. Sometimes it will become for 20 marks. So if it is 20 marks, see that marks and which are the test. List the test and how we are going to conduct it. 3 to 4 lines, if possible, draw the diagrams. Okay, normally you won't ask the test specifically, like how we are going to conduct the fineness test, how we are going to conduct the VB test, and all those things will not be asked. So the one single question will be there, like, okay, which are the different tests are going to conduct on a cement, on the cement. Okay, try to highlight all the tests and um, which are the important, what is the test, and what is the procedure in 3 to 4 lines. Then if possible, try to draw a small diagram. Okay, so then basic classification of concrete depending on the state is classified into two types, that is a fresh concrete and the hardened concrete. Okay, so it can be placed into forms to produce light weight structural elements. Then it is a strong compression strength but lacks in tensile strength. Okay, this you already know. Very important in this, properties of concrete. The properties of concrete play an vital role in making good quality of the concrete. So when we already classified into two main classifications. Of course, if you go in detail, we have geopolymer concrete, we have um, um, the pervious concrete, and all those things are there. Okay, this is the basic classifications. If you go in detail, there are different based on the applications. Different types of concretes are there. Like you have geopolymer concrete, then you have pervious concrete. We have pervious concrete, then non-pervious. So like that, you have different low heat strength concrete, or then have the concrete which is going to resist even for 1000 degrees centigrade. Okay. High temperature resistant concrete. Okay. Like that, many concretes Based on the application, it will be used. But basic property, that is the fresh concrete and the hardened concrete. So first one, that is always the workability, and when it comes, it will be the strength. We'll always concentrate on that. See, what is this workability? It is normal. It is, we are going to conduct with the help of the slump cone test. Okay. When you say it is workable, when you say it is when you say it is workable, it is the,
Sir, when it is working, sir.
hello.
Hello, sir.
Uh, any network problem is happening?
Sir, I think it's your side on this problem, network
Okay,
problem.
okay, okay. Just a minute. Okay, fine. So workable means it is the ease of placement. You are, once you prepared, once you do any mixed design, it should be ease for the placement. So this one you have to remember. Once it is ease for placement, what are the fresh concrete we are talking about? Okay, if it is satisfying, the ease of placement is satisfying means almost all the properties of settlement, that is slump, what we always talk about. The slump means it will be settle, easy to settle. So this you have to always remember. If the slump you are maintaining properly, then always it will be workable. That only you have to remember. So when you say it is hardened, once it is cured for 7 days or 20 days or 14 days, like that, it has to give its strength as for the norms given by the board. Okay. Then segregation, bleeding, impermeability, durability, so dimensional variations, so that all the things you have to maintain in the properties of the concrete. Okay. So then workability of the concrete means it is ability to do with the concrete. That what I said is that is for the placement. Okay. This has to be conducted for using this slump test, compaction factor test, and wave test. Okay. So this is the slump test. You already know this. Okay. We will try to skip this because the repetition will be there. That is the vertical settlement of the fresh concrete after the mold has been withdrawn. First you have to fill it, then withdraw it. Okay, measure the slump. Okay, so of course it is not suitable for very wet and very dry concrete mixes. So not suitable when aggregate size is more than 40 mm, because the break of the slump is going to happen if you use more than 40 mm aggregate. Suitable for concrete of medium to high workabilities. Okay, therefore this highest scope. Then compaction factor test. Then exactly just refer this highest scope because you already covered in the UG as well as the last year lab also. Possibly when the class will start, we have the demo also. The lab. So the swim test, um, not suitable for concrete of high workability, slump above 75 mm. Suitable for concrete with low or very low workability. Okay. So we require uppers. At the bottom you can see the vibrating table, it will be there. Here. Then elastic support, it will be here. Then a cylindrical container, it will be there. Then metal cone, then iron rod will be there. Refer this IS code. IS code. Okay. Now exactly the wave time and the slump. You see it. You can see the graph. Okay. So then hardened concrete, of course, always will find with the MP or Newton per mm square per meter square. Okay. Pascal. So this we already covered. So compression strength, tube test and cylindrical test. Normally we'll go with these two. Okay. So standard dimensions will be there for this. Okay. You are conducting the tube test. Okay. Um, higher molds of 150 mm by 150 mm by 150 mm. So the clamping equipments, the clamps, then oil. Normally we'll uh, put it before placing the concrete, so that when you are removing it, it will be very easy. Then a steel roll, trowel, so trowel for mixing. So then CTM is required. That we already covered whenever we are covering with the cement properties. Okay, this is precision mode. The cylinder modes. This all the things are required. So then slowly um, we'll move on to the tests on bricks